Okay, now I'm going to put everybody's hands down right now. I'm going to put everybody's hands down right now. And I want to ask you guys a question, a really, really important question. Did anybody come up with a sequence of numbers that they could not solve? So what I'm looking for from you guys is this. 5 cards, 5 numbers that you chose, and a target number that you chose, but you couldn't solve it because those are the most fun when we can try to solve the ones that you guys have trouble with. And I had a lot of mathletes looking at ways to solve those problems. So does anybody want to raise their hand and tell me about something that did not work out for you or that was really, really hard? So I'm going to go first. Let's see. We're going to do it all. And I'm first going to go with Lucia. I have unmuted you, honey. Go ahead.
One was hard for me, 6.
So 6 was the target number?
Mm-hmm.
Okay, so 6 was the target number. And what were the other cards?
I forget. But I know it was really hard because my brother didn't even know how to do it. And he's 12.
Is there any way that he's there or you can find out now what they were? Because if we know the 5 numbers, we can try to solve it. So is your mom or dad there that maybe could help figure out what those were? So why don't you go figure that out and I'll be right back with you. So let's see. Avery, do you have one that would be difficult for us to all solve?
On page 3, the target number was 8.
And what were the 5 cards?
8, an ace, a 4, a 10, and 8, and a 7.
All right. Now, I want everybody working hard to try to figure this out. Who can figure out how to get 8 from 1, 4, 10, 8, and 7? So go to it right now. Pick up that pencil. Remember, this is your secret weapon. That pencil married with your brain creates beautiful math. So let's see you guys go for it. And I'm going to try it myself. And let's see if we can help Avery with this really, really difficult problem. Let's see. What do we have? What do we have? I see Now, I see that Gabe has raised his hand. Gabe, do you have a solution to this one?
Right now, while you're sharing the screen, I can't really see the target number.
Oh, well, you know what? Let me stop sharing and share again and see if this fixes it. Gabe, can you tell me if that fixed it?
No, I can only, no.
Okay, so you can still, so Gabe, how about now?
Yes.
Can you see it now, buddy? Is that a yes or a no, buddy?
Yes.
Excellent, excellent. Okay, I'm gonna call on Cam. Cam, do you have a solution?
No, it's just that I can't see it. I can't really see the target number.
And so you can't see it now?
No, you can see.
Oh, yeah, now I can see it.
Okay, that's great. That's great.
The number was 7, but it's 8.
Ah, it is 8. And so, Andrew, I'm gonna call on you. Do you have a solution to this one?
No.
So I'm really, really excited to see if anybody has a solution to this one. So I want everybody to stop for just a second because I have some ideas. Guys, what happens if we add 8 and 7? Can you guys say that on 3? 8 plus 7. 1, 2, 3, go. 8 plus 7 equals 15. Now, I have 15. Can anybody tell me what I might do with 15 and 10? Who can tell me what to do with 15 and 10? Who's got an idea? Who's got an idea? Come on, let's do it. Let's do it. What do you think, Lucia?
You could like take away and then
Oh, can you repeat that, honey? Because it didn't come through.
you could take away 10.
Ah, so 15 take away 10, and tell me what that is.
What is it?
Anybody know what
I have a
15 take away
solution.
10 is? Say it out loud. It is 5. And everybody, what do you think we want to do with 5 and 4? What do you think we want to do? Say it again. Say it out loud.
Add them. 5 plus 4 is 9.
If we add 5 plus 4, we get what, everybody?
9.
9. And what do you think we should do with 9 and 1?
Minus it.
And guess what? Avery, you gave us such a difficult one, and I'm so proud of you for doing that because that was really, really hard. Cam, what do you have for me?
I was gonna say 9. I was gonna say 9 minus 1 equals 8.
Awesome. Awesome. Well, guess what, guys? I thought that this was the best game in the world until I looked around the world. Oh, and Tess, did you have something else you wanted to add to that?
No.
Okay, cool. So, and how about you, Victoria? You have your hand up, honey.
It's not exactly for the whole thing, but I thought that once we got 15, we could do 10 minus 15 and then end up with 5, and then we add the 1 to the 4, which equals 5, and then we do 5 minus 5, and then we lose it.
That's right. That's right. Victoria, that is a beautiful, beautiful thing. Now, guys, I'm going to share with you right now a game that might be even cooler. A game that might be even cooler than target number. Are you ready? And the game is called 24. The game is called 24. And the reason why I love this game so much is because 24 is a number that you can get so many different ways. So many different ways when you add numbers, subtract numbers, multiply numbers, or even divide numbers. Now, the way 24 works is 24 is always the target number. So I want you guys to write down the number 24 right now. Everybody write down the number 24.
Okay.
So the number 24 is your target number. Now, what's really cool about this is that your job, because I gave you a bunch of cards, and this card has a 7, a 7, a 7, and a 3. Now, when I play this game, I don't think about all the numbers at the same time, and I don't think about the numbers by themselves. I put numbers together in pairs. So I might do something like 7 plus 7 equals what? Say it on 3. 1, 2, 3.
14.
And then I might do 7 plus 3 equals 10. And then what should I do with 14 and 10, everybody?
Add them.
I could add them together and boom, I get 24. Now, look, could I have just gone 7 plus 7 plus 7 plus 3? And would that also be 24?
Yeah.
How many of you see that 3 sevens is 21? How many of you know that math fact? That's a really,
That's
really
easy.
cool math fact.
I didn't do that.
Avery's got that. I think Andrew's got that. Hayden's got that. And Cam's got that. And guys, 7, and do you know when I learned this? I learned this from football. Because when I used to play football, back when I was your age, every time you got a touchdown and you got an extra point, you would get 7 points. And every time I got 3 touchdowns for my team, I knew that we had 21 points. When I had 2 touchdowns, I had 14 points. How many points did I have after 4 touchdowns when I made the extra point? Who knows? Who knows? 4 touchdowns times 7. Who's got that? Think about that. Think about that. Now raise your hand electronically. And I'm going to go with Sabrina. Sabrina, what do you have, honey?
It's 28.
Yes, it is 28. That is awesome. So guys, guess what we have here? We have a strategy all about football. Now, I'm going to ask you guys another question. By the way, Avery, do you have another thing to add to that?
Okay, Cam, don't pick the nose, please.
Avery, did you have something to add to that, love? All right.
No.
Okay, no problem, no problem. Now, the question is there another way to make 24 with these numbers? Who sees another way to do that? And I see maybe something else we could do. Maybe something else we could do. Huh. Does anybody see anything else that we can do here? Or would you guys like a new card? Would you like a new card? You want a new card? I'll get you a new card. So this card here is going to be 8, 2, 4, and 4. And remember, our target number is always 24. Now, I want to ask you a question. Can you think of 2 numbers that would make 24 that would be really cool? And Cam, you're raising your hand, buddy. Go for it.
It's just your screen's too big. I can only see the card.
Yeah, we can't see that.
My screen is too
Can't see
big.
the
Okay, so
top
I'm
number.
going to
You can only see
try.
the card. It's too big.
And Cam, I
Oh wait,
really.
there it goes. I fixed it.
Oh, you fixed it?
Yeah.
Okay, that's great. Now, who's got a strategy here?
Can't hear it. Turn it off.
I'm thinking
No,
about
it's
some
already up.
really, really cool numbers. Who's got a strategy for me? First, I want to ask you guys a question. Does anybody know
Speakers in the
what happens when I take 32 and I take away 8? Don't answer it out loud. Think about 32, and you might want to first take away 2 because that gets you to 30, and then take away another 6. So when I think about 32 take away 8, I think of 32. I think of 32. Don't say it out loud, please. Don't say it out loud. I think of 32 take away 2 plus 6. So what did you guys get on 3? 1, 2, 3, go. Whoa. Now wait a minute. If that's true, can anyone tell me how to make?
24.
Good. Can anybody tell me how to make a 32 and an 8? Because if I know my strategy is to find a 32 and an 8, who knows how to find a 32 and an 8? And this is going to require repeated addition, or as older students would say, multiplication. How could I make an 8? Let's go with the easier one first. Who has an idea how to make 8 from 2 cards? Who could help me make 8 from 2 of these cards? Does anybody see it? Gabe, do you see it?
4 plus 4.
Whoa, I agree with that. Now, Gabe, the only problem with that one is that if you use 4 plus 4 to make 8, how are you going to make 32 with 8 and 2?
Wait.
Because 2 8s is only 16. Tess, is there another way, Tess, for you to get 8? Is there another way, Tess, for you to make 8 from the numbers we have here?
The 1-8 card.
I could use the 8 card, and then I would have to use the 4 and the 4 and the 2 to make 32. That's kind of cool. Lucia, do you have a way to do that? Go ahead, Lucia. Tess, that was a beautiful idea. Do you have an idea, Lucia?
My other idea is you could do 2 times 4.
Oh, wait a minute. You know what? Let's try that one first, and then we'll try Tess's idea. Okay? So let's try
I already know.
2 times 4. Everybody knows that 2 4s equals 8. Now, how do we make 32 from 8 and 4? Who knows how to do that? What happens if I took 8 plus 8 plus 8 and 8? So 4 8s, or 8 times 4. Who knows what happens? Would you guys like to count with me, starting with 8? We're going to add 8 each time. Are you guys ready? Let's go first. 8 plus 8 is, say it.
16, and then the end, 32.
And 16 plus 8 is what? Come on, guys. You can say it.
24.
24. And then 24 plus 8 is what?
32.
Guess what? You just got 32 and 8. And now we could do 32, take away 8 to make 24. That was awesome. That was awesome. Now, Tess, we're going to do your idea now. Are you ready, Tess? Now, Tess, we're going to do your idea. Now, Tess's idea, she said, Mr. Kramer, you already have an 8. Now, all we have to do is make 32 from 2, 4, and 4. Who sees how we could do that? There's a couple of different ways. Who has an idea? Who has an idea how to make 32? And I'm going to give you guys a little bit of a hint. Are you ready for this? I'm going to draw you a special square. And this special square is a 4 by 4 square. What happens when you have 4 4s? So 4 plus 4 plus 4 plus 4. Who can say what is 4 times 4? Go.
24.
If you said 16, guess what?
16.
Come on, say it out loud.
It's under the table.
Can't we do 16 times 2?
Yeah.
Everybody, let's do it. Who knows
32.
16 is 10 plus 6?
30.
And 16 is 10 plus 6. If we do that 2 times, we get 20 plus 12, which is 32.
2.
Guess what? We did it again. We did it again. Now, I want to challenge you guys
Nothing everywhere.
one
Sleeping.
more time on this one. Are you ready for this? Now, on this one here, here's what we're going to do. Mr. Kramer is going to erase everything on the board. All of our hard work, we're going to erase that. And then what I want to do is I want to throw out a new math fact. Are you ready for this? There was something that happened when we were adding 8s. Who remembers what happened when we did 8 plus 8 plus 8 more? Who remembers what happened when we did 8 3 times? Raise your hand electronically, please, if you remember what happened when we did 8 3 times. 8 plus 8 plus 8. Who remembers that? Who remembers what we did? And so I have, let's see, I have Sabrina and Hayden. Could you let me know what happens when we add 8 3 times? Go.
24. 24.
24.
Whoa. Does everybody, didn't we do 8, 16, and then 24? Didn't we do that? Didn't we do that? Well, wait a minute. If we know that 8 times 3 is 24, do you see a way for us to find an 8 and a 3? Who sees a way for us to make an 8 and a 3? Who sees that strategy? So I want you guys to think about that a little bit. I want you to think about that a little bit. How do we find an 8 and how do we find a 3? Who sees the 8? Who sees the 8 right now? Ava, do you see one?
On that card.
Yeah, we already have an 8, guys. We already have an 8, just like Ava said. Now, if you have the numbers 2, 4, and 4, how can you make a 3? I have my 8, but I need a 3. And all I have is the cards 2, 4, and 4. Who's going to help me? Who's going to help me do that? Come on, guys. I need help. There is no way I can do this by myself. I have a 2, a 4, and a 4. Huh. How do we make 3? Victoria, how do we do that? How do we make a 3, Victoria?
Well, I just thought there might be a way for us to do it, but I was going to ask if you can subtract the time.
So when you said, can we subtract, we definitely can subtract. But what do you want to subtract? What 2 numbers?
Well, I don't quite remember what I thought, but there was something I thought. I'm just asking if you can subtract the time.
You're allowed to subtract, but times means multiplication. So 8 times 3 means 8 plus 8 plus 8. But let's say that you wanted to take 4 minus 2. That would give you a 2. The problem with that is then you have a 4. How am I going to go from 2 and 4 to get to 3? Now, I want to ask you guys one question. Do you guys know of a way to get to 3? Who can tell me, raise your hand electronically, if you can tell me some really easy ways for us to get to 3? Who can do that? And I'm going to start with you, Avery. Give me one special way to do that. Go ahead, Avery. And I'm trying to unmute you. There you go, kid.
You can take 1 plus 2.
Oh my gosh. Everyone, 1 plus 2 or 2 plus 1. Does anybody see a 2 anywhere on the game board? Who sees a 2 on the game board? Where is it? It's right there.
Yeah.
Now the big question is, how do we get 4 and 4 to make our 1? Who remembers from last week? Who remembers from last week a very special strategy to make 1 from any number and itself? And Hayden, I'm going to call on you. Go for it. And Hayden, I think I muted you by accident. Sorry about that.
4 divided by 4.
Wait a minute. Everybody, if I take 4 and I divide it into fourths, do I get 1 whole? Let's try this out. Here's a square. I'm going to divide it into 4. If I take 4 and I have 4 fourths, how much do I have, everybody?
1 whole.
1 whole. If I do a circle and divide that into 4 fourths, I get 1. What would be, how about Sabrina? Sabrina divided by Sabrina. What's that going to be?
1 whole.
That's going to be 1 whole. Now, what about Mr. Kramer divided by Mr. Kramer?
No.
1 whole.
That's gonna be 1 whole. Now, how about Paul divided by Andrew? What's that going to be? That's going to be trouble. No, I'm just kidding. That would be wonderful. But we can't do that because we don't really know Paul as a number and Andrew as a number. So it has to be Paul divided by Paul is 1, or Andrew divided by Andrew is 1. And therefore, everybody, since 4 divided by itself is 1, we now have our 1, we have our 2, 2 plus 1 is 3, 3 times 8 is 24. Isn't that a really cool one? So I really love that. Now, the next challenge I have for you guys is this. I want everybody right now to go to page 1 in their packet. Go to page 1 in your packet. And if you go to page 1 in your packet, it has all the different ways to make 24. So I can start with 0 plus 24, 1 plus 23, 2 plus 22. And does anyone see a pattern here? Can anyone share a pattern that they see here? And I want to get everybody thinking about this. So I want everybody thinking about a pattern. And I want to hear from people I haven't heard from before. Well, actually, I've been hearing from everybody. Paul, what about you? Do you see a pattern here? 0 plus 24, 1 plus 23, 2 plus 22. What do you see there? Tess, what do you see there, kiddo?
There's going down on the first spot, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on the second spot, 24, 23, 22, 21, 20, 19, 18, 17, 16, 15, 14.
Wow. Now, who can tell me why Mr. Kramer stopped at 12 plus 12? Who can tell me why I stopped at 12 plus 12? Lucia, do you have an idea about that? Do you have an idea about that? I can't see you, but I see that you have your hand up. Go for it.
I didn't mean to raise my hand.
Oh, no worries, no worries. Victoria, what about you?
I think I know why you stopped
Why
there.
didn't I go 13 plus 11 and 14 plus 10? Why did I stop at 12 plus 12?
I think because it was the same number. It wasn't like one bigger and one lower.
Oh, so are you telling me, wait a minute, Hayden, do you see something, or Sabrina, do you see something as well?
I think he stopped at 12 plus 12 because it equals 24.
You know, that is true, but who can tell me what happens if I kept going? If I kept going, what would happen? What would happen, Ava? Go ahead, Ava.
I didn't raise my hand.
Okay. Avery, what do you see, honey?
It wouldn't equal 24 anymore.
But wait a minute. What happens if I do 13 plus 11 and 14 plus 10 and 15 plus, come on guys, 9 and 16 plus 8 and 17 plus 7 and, come on guys, help me, and 18 plus 6 and 19 plus 5. Why did I stop at 12? Sabrina, go.
Because you already did all those numbers.
Yes, everybody, these are just called turnaround facts. Now, turnaround facts is what they tell you in school in first grade and second grade. But guess what? It actually has a special name. Would you guys like to hear the special name?
Yeah.
It's called the commutative property. Everybody say that. Commutative property. So if you have a number like 13 plus 11, go like this. 13 plus 11, and then 11 plus 13. 13 plus 11 equals 11 plus 13. It doesn't matter what order you do addition. And what do you have there, Victoria?
It's a sticker from Harry Potter. It's for my coding wand.
Oh, good. I thought you were trying to show me something on the screen. Now, everybody, look at the subtraction. Everybody look at the subtraction. So I'm going to put everybody's hands down just so we can start over. If we look at subtraction, 24 take away 0 is 24. 25 take away 1 is 24. 26 take away 2 is what?
24.
And who sees a pattern? Who sees a pattern?
1, 2, 3, 4, 5, 6, 7,
Wait,
8, 9.
not out loud. I want everybody to have an opportunity to see the patterns here. So who sees the patterns? Who sees the patterns? I'm going to start with you, Lucia. Go.
I see the pattern. It's like, so 24 minus 0, but then for like 25, you take away, make it 24.
Right. And then what happens next? And who can Tess, do you have an idea about that too? Go for it, Tess.
On the left side, it's going up, and the right side, it's going down.
Is it? So from 24 to 25 to 26 to 27 to 28, but on the right side, is it going down?
It's going up on both sides.
Ah, So Hayden, what do you see?
I just forgot to lower my hand.
No problem. So guys, what if I did 50 take away 0? What would that equal, guys? Go.
50.
Now, what if I did 55 take away 5? What would that be?
50.
What if I did 60 take away 10?
50.
50.
So if I add any number to 50, let's say I add, how about 24? If I add 24 to 50, I get
74.
74. If I add 24 to 0, I get 24. So 74 take away 24 must be what, guys?
50.
And that is also 50. Isn't that a cool strategy for subtraction? Isn't that a cool strategy? And guys, it gets better. Watch this. 24 take away 0 equals what?
20.
24.
So what about 1,024 take away 1,000?
24.
24.
What about 1,024 take away 1,000,000?
24.
So whatever I do to one side here, I do to the other side, and it always gives me the same result. And I love, love, love that. Now, are you guys ready for this? The next thing I have to show you is multiplication. When Mr. Kramer thinks of multiplication, I think in rectangles. Do you guys think in rectangles?
No.
I always think in rectangles. So when I look at the number 4 times 6, I always see 4 squares by 6 squares. And if I count by 4, let's do it, guys. Go, go. 4, 8, come on. Everybody do this out loud. 12, 16, 20, 24. Oh my God. Did you guys just get 24 squares? You did. Now, what if we did 2 times 12? Let's count by 2s. You ready? Go. 2, 4, 1, 6.
8.
10, 12, 14, 16, 18, 20, 22, 24.
And guess what, guys? You just solved 2 times 12 is also 24. What about 1 times 24? What would that be? 1, 2, 3. Are we really going to count by ones?
5, 6,
6, 7, 8, 9, 10, 11, 12, 13, 14, 15,
10,
16,
11, 12,
17, 18, 19, 20,
13,
21, 22,
14,
23,
15, 16,
24.
17, 18, 19, 20, 21, 22, 23, 24.
Oh my gosh. Now, guys, do you know that doing 24 is so much fun? But isn't it also fun if you find different ways? Like, what about 8 times 3? Let's count by 3s. I want everybody to help me. On 3, we'll start with 3. 1, 2, 3, go. 3,
6,
6,
9, 12, 15, 18, 21, 24.
oh my God, you guys did it again. This is crazy. You came up with now 4 different ways to multiply 1 times 24, 2 times 12, 4 times 6, 8 times 3. So now, if we were to go, let's say that we were to go over here and say, what can I do And I want to show you, let's go to a certain page now. The page I want you to go to is page number 2. Everybody go to page number 2 right now, please. And what I did for you on page 2 is I created a special challenge. Everybody go to page 2. Now, in page 2, you can choose any way to make 24. So the first way Mr. Kramer chose was 1 times 24. You guys remember 1 times 24 is 24, yes?
Yeah.
All right. So what I'm going to do is, and I'm going to mute everybody so it's a little easier to see and listen. I want you to create a card, create a game card that would have a 1 and a 24. So notice how on this game card, Mr. Kramer made 7 and a 6. Why do you think I made the 7 and the 6? On 3. 1, 2, 3, go. Come on, guys. 7 take away 6 is what?
1.
Is 1. That's exactly right. Now, who can tell me how I was able to make the 24? Using 8 and 3. Who can tell me how? Raise your hand electronically on 3. 1, 2, 3, go.
3 times.
Say
8
it, guys.
times 3 is 24.
8 times 3 equals 24. So I made a game card by creating first my 1 times 24, and there it is. Now the next one I made was 10 plus 14. Do you guys like that math fact? 10 plus 14, do you guys like that?
24.
How do we make a 10? And I chose what? 6 and 4. How do we make a 14? 7
7
times 2.
2.
7 plus 7. 7 repeated. 7 times 2 is 14. 6 plus 4 is 10. And that's how I did mine. Now, I'm going to challenge you all to write down a new challenge. So I want to do a challenge for you that would do a 8 times 3 challenge. So our challenge is 8 times 3. Everybody right now, write that down right where I did right here. 8 times 3. And I want you guys to come up with 4 cards. 2 of the cards has to make 8, and 2 of the cards has to make 3. How can you make that happen? Who's going to really work hard?
I don't get that.
Well, let's see. Think about how I made a 1. I made 1 by doing 7 times 7, take away 6. 7 minus 6 is 1. I made the 24 by doing 8 times 3 is 24. So how would you make an 8? Who has an idea on how to make the 8? Who has an idea on how to make the 8? Raise your hand if you can give me 2 cards to create the 8. And I'm going to go with Avery first. Go.
4 plus 4 equals 8.
Guess what, guys? I'm going to write it down. 4 and 4 because that makes 8. Now someone else has to give me a 3. How can I get a 3? Writing down 2 numbers. And I'm going to go with Sabrina and then Hayden and then Gabe and then anyone else. Go girls.
1 and 2. 1 and 2.
Oh, I love it. 1 and 2. Now, is there another way to do it? 4 and 4? Is there another way to make 3? Who's got that, Gabe?
Mm-hmm.
Gabe, how can I also make a 3?
3 and 0.
Ooh, 3 and 0. Now, I never said that you couldn't have 0 on your card, did I? So I like that a lot, Gabe. I like that a lot. Now, who's going to come up with another one for 8 times 3? 8 times 3. One more. Anybody else have another idea? And I want to really open this up. Tess, what about you, honey?
4 minus 1.
Ooh. So you decided to use a 4 and a 1. And do you have a different way to make 8?
5 plus 3.
I love it. I love it. That's another beautiful way to create an 8 times 3 card. And Avery, do you have one more for me?
I have one.
The 3, it could be made by a 2, a, 1 and a 2, and then the
Go ahead.
and then the 8 is 7 plus 1.
Ooh, I really, really like that one. Now, I want to move on to one other idea, guys. And here is my idea. What would you say if I gave you guys dozens and dozens of playing cards? So I gave you dozens and dozens of playing cards. Now, let me show you. That's the easy ones. The easy ones have 1 dot. I want you guys to start with the easy ones. Start with the 1 dotters. There's another 1 dot, another page of 1 dot, and then we get into the 2 dot cards. The 2 dot cards are actually a little bit more difficult. The 2 dot cards are a little bit more difficult. And I gave you 1, 2, 3 pages of 2 dot cards and 4 pages. And finally, we get to the 3 dot cards. Now, the 3 dot cards are really, really challenging. So I do not recommend that you start with the 3 dot cards, but I want you to work your way up. What you can do is you can cut out the cards from the printed sheets that when your parents printed those sheets, you can actually cut out those cards, or you can just write down the numbers. Hayden, do you have an idea?
I have a question.
Yes, sweetie.
So do you like make up the times you're doing?
Well, for instance, Hayden, when I use a given card, so let's say that I take a card and I'm going to choose one right here. Can anybody choose a card from this page? Somebody choose a card from that page. How about you, Paul? Go ahead and choose a card.
2, 2, 9, and 8.
So 2, 2, 9, and 8. Let me see if I can find that. 2, 2, 9, and 8. 2, 2, 9, and 8. 2, 2, 9, and 8. And can you help me find it, buddy? Oh, there it is. Oh, you know what? That's actually a 6. But I'm going to choose that one anyway. And the way I know that it's a 6, Paul, is that the line is underneath. The line is underneath. So do you see how if we turn this around, Paul? I'm going to do that right now. I'm actually going to turn it around. Do you see how that's actually a 6?
Yeah.
Okay. So Hayden, this is to your question. If you start out with a set of cards, you know your target is 24. You have to figure out a way to make 24 from these cards.
But like, what if like the one we just did times 3? Can you just like choose the times you're doing?
Yes, yes. So let's say that you're doing the challenge that I gave you here. Remember this challenge? You actually get to choose whatever card you want. So you can choose, hey, I'm going to choose to put the numbers 12 and 12 together. You ready for this? Let's choose 12 and 12. I want to make a 12. Everybody give me a 12 on 3. 1, 2, 3, go.
10 and 2.
10 and 2.
2.
But now I need another 12. And I'm going to
It's
do,
the 6.
or
9
9 and what?
and 3.
And I also could do 4 and 3 because 4 times 3.
Can you subtract?
Of course you can. So how would you make
11.
12 with subtraction?
13 minus 2.
Well, 13 definitely minus 1 would be 12. 13 minus 2 is 11. So there's 112. Can anybody give me another way to make 12?
6 and 6.
Go ahead, say it out loud.
6 and 6.
And 6 and 6. So Hayden, when you do these, you have to choose your math fact to make 24, and then you create the game card on your own.
4 and 7.
But when you do this one here, this is more challenging. Now, who can tell me a solution with the 2, the 2, the 6, and the 8, the one that Paul came up with? Who can come up with a solution for this? And Andrew, I want you working hard. So pick up your pencil. Everybody should be picking up their pencil and be thinking about different ways to make 24. Different ways to make 24. And I'm going to throw some hints out here if I can think of them. I'm going to throw some hints out to see if I can think of them. I kind of see a cool one, guys. I wonder if anybody can make a 6 times 4 with these cards. Could anybody make a 6 times 4? So you'd have to make a 6 and you'd have to make a 4. Can you do it? Who's up for this? Come on, who's up for the challenge? So I want everybody working and see if you come up with a solution. I've already got Avery raising her hand. And Avery, keep thinking of different ways to do it. Keep thinking of different ways. Who's got a great solution for me? Who's got an awesome, awesome solution? Come on, Lucia, I need you working here. And Tess, I don't see you anymore. So I'm gonna try to do that. And let's see who, oh, Cam, there's Cam. It's got it. And Cam, turn off your virtual screen so we can see you because you keep going in and out of that screen and it's kind of hard to see it. So I wanna start with Avery, who has an idea, Avery, about how to make 6 and 4. Go for it.
We already have an 6, and then I was thinking 2 plus 2 was 4.
You know what? We already have a 6, and 2 plus 2 is 4, but we have one little problem with that. We have one little problem with that. And the problem is you never used your 8. You have to use the 8. How can I use the 8 and still get my 4? Avery, that was an awesome idea, but I want someone else to help Avery get to 4. Come on, Ava. I want you picking up your pencil. Pick up your pencil and work that. You have a 4. You need to get to 4, but you have to use the 8. Gabe, go for it. You'll have to unmute yourself. There you go.
What about 10 times 8?
Well, 10 times 8 is what number, Gabe?
Mm. 80?
What? It's 80, right. Now, how are you thinking of using 80 to solve this problem? Remember, our job, and that was a really good start, and our job is to go from a 4, use the 8, and somehow get a 4. Who's got that? Come on, Tess, do you have that solution for me?
8 minus 2 minus 2.
Yeah, or how about just 8 minus the 4? So if you take 8 minus 2 and minus 2, that also gives you 4. And 6 times 4 is 24. Beautiful, beautiful job. Now, you guys did an amazing, amazing job. Victoria, you have your hand up. Give me your idea.
Well, I just thought that we can take the 2, and since that equals 4, we can do 8 minus 4, and then we still have a 4 left.
That is right. So 2 plus 2 is 4. 8 minus 4 is 4. 4 times 6 is 24. Did anybody come up with another way to make 24? Did anybody come up with another way to make 24 here? I have one other way that I want to show you. Would you guys like to see Mr. Kramer's fun way? Now, are you guys ready for this? Who can say out loud, 6 plus 8 is what?
14.
And 14 take away 2 is what, everyone? Go.
Is 12?
12. And what do I do with the 2 that's remaining and my 12? How do I get from 2 and 12 to make 24? Come on, guys. 12 times 2 is 24. And that is another way to solve it. Now, if you guys send me pictures of your solution pages. So for instance, what I would love to see this week is I would love to see you send me pictures of your page 2. If you send me pictures of your page 2 and page 3, which has all of these opportunities to create your own cards, I might even make my own game based on your cards. Would you guys like that? Would you guys like if I made a game based on your cards?
Yeah.
Well, guess what? Get started right now. So we're going to count right now, everybody, from negative 24, and we're going to add 4 each time to get to 0. Are you ready? Set,
Let's go.
go. Negative 24, add 4.
Negative 20.
20, add 4. Negative 16, add 4.
Negative
12, add 4.
Negative
8, add 4.
Negative 4.
Add 4, and what do you get? Don't ever say negative. 0, 2, 4, 6, 8. Who do we appreciate? Mathletes. Mathletes. Go Mathletes. I will see you guys in hopefully in 1 week, a little more than 167 hours, because I think that class is going to be at 3:30. So it'll be 169 hours. Exactly 169 hours. And I want everybody to say goodbye to their friends, and we'll see you next time. You guys were amazing.
Bye.
My favorite games, guys. I'll talk to you soon. Bye-bye.
Bye.
Bye.